All right, I'm gonna give it another update on this app. Uh, Last time I said I was going to be running simulation for a while and seeing what happens after it ran for an extended amount of time, but that did not actually happen because I found a bug in the way it. Well, at the time, what I noticed was there were some state numbers that were being repeated in the machine, so something was wrong. I didn't know if it was maybe the right way it was mutating, um, or something else. So what I ended up doing, I hadn't had much time to work on it, but until yesterday, and then so what I did was I did track down that bug, and it had to do with the way it was when you saved off the world and loaded it. So there was some value that wasn't getting initialized. It was reusing uh, some state numbers that already existed whenever it did the random mutation to add a new state. And then I did comb over a lot of the mutation stuff again. I did notice some little issues with the way it mutated. It wasn't quite mutating the connections correctly when it modifies a random connection. Wasn't modifying it quite right. I think that in principle it still worked, but it wasn't modifying any connection. It was only being able to modify some of them at a time or something. The mutation wasn't working as good as it could. So I did adjust that code. I added some more statistical options, um, and I did the world I showed last time. Uh, I that is the world I've been running. Yeah, this is the world I had started off and been running it for maybe, I don't know, between a half a day and a full day now. Um, Basically the same as last time, where there are these machines that can attack, and this one moves backwards. Or this one moves. Um, I'm not sure. One of them, basically, they do the same thing as the original, where they move left, look around for food, and move left. But if they also encounter another machine, it will approach it and attack it. And these are four different variations of it. And the only thing different between them is the direction they move. Like this one will move up, this one will move down, this one will move left, and this one will move right. And I also added a bunch of these stone objects. So they're like obstacles, but they could be used potentially in some future generation of these machines. Maybe they'll figure out how to push and pull them and maybe use them somehow to benefit themselves. And a lot of these green memory objects. Um, so yeah, I put them all right next to food, and I scattered a bunch of food around as well, so that as soon as they spawn, there should be easier for them to find foods. Uh, so when this thing would start off, it would look like this at first. And you see up here, I am putting the current time counter on the title bar here, along with the maximum mutations, because the way it was before, you would not see this information unless you stopped stopped it from running and then clicked on any of them. And then I have it included on the side here, max mutations. That's just like how many consecutive mutations exist of all the machines. What's the largest number of consecutive changes uh, that exist? Just to get an idea of how far they're developed. And I also added these three statistical things, like number of states on the Turing machine that you have clicked, number of how many of those states are final states, and how many connections are formed. So you see it starts out like 8, 2, and 20. Now I'm gonna fast forward and load the later instance. the latest one. So we are at time almost 11 million units of time later, and like this machine has 240 states, 230 of those are final states, 258 connections total. It seems that the mutation does kind of favor that design where uh, it does tend to create just a lot of final states that just generate output right away without doing anything complicated yet, as far as maybe a loop, um, some kind of loop or conditionals. And it does, and it's good in a way because then there's many computations to complete one unit at a time for each of these machines. But over time, I would hope that they start doing more with loops and stuff. Maybe they do. I'd have to look at the connections. And you can see that they're doing a lot of like the eat operations getting used heavily. It's about a billion times that they've eaten and while running this, and done a lot of attacking, moving left, right, up, down. This is the push operation has been used slightly more than otherwise in all these other operations. So it makes me think, except this one. Yeah, I don't know if that means that maybe they occasionally do stumble onto like a push operation that turned out to be useful, but at this point, really, they haven't really done anything with that yet. Same with like the memory save, nothing significant there. So the other thing I added was an option to automatically save. So I'll demonstrate that. So you go here and you click on autosave. It says it's currently off, so to turn it on, you would click on it. You'd save the file format. The way I have it work is when it saves, it'll look for the period and just put the world time elapsed number in there. So first I'll specify the file format. Then it asks like how often do I want to save, and for the testing I have it. So you need at least 10,000 for every autosave. I mean, it's probably going to be a number a lot larger than that. But just for demo purposes, I'm going to use the lowest number I support. I didn't want to go below 10,000 because then it's just creating tons of files in your hard drive. So autosave, jumping 1,000 at a time here, and I'll turn it on. Eventually, you'll see a new file appear down here. And it's going to come in handy because what I'm going to be doing is just letting this thing run all the time, and maybe I'll have it save every million, maybe. Might save every million. And that way, sometimes computers crash or the app would crash, and if that were to ever happen, at least all the work wouldn't have been lost. All the time used to advance these machines. Okay, I did one already. And then it'll save again when it gets the unit time gets to 10,989,033. Stop this for a second. You can see how it's saving it here. It'll tell you in the menu caption here. It's neat that I do see this max mutation number fluctuate both up and down. So when it goes down, that means there was somewhere on the map there was a machine that had more mutations, like the way it just did right now, 2,230, and then went down 2,229. Well, the one that had 2,230 consecutive mutations, it was experimenting with a random change, and the random change just didn't pan out, so it died, and yeah, that's why you see it fluctuating like that. But it went down again. But over time, it has been increasing. That's to be expected. Sooner or later, it should bump into a change that's beneficial. Okay, and you can see that. Yeah, it's taken about 2 minutes to get past about 10,000. So I can slow it down now even more, and we can. I haven't looked at them a ton. Like, as far as now that there have been over 2,000 changes, what kind of change in behavior are we noticing? Definitely different movement changes, like this guy keeps going back and forth. There's a lot more variation. They aren't, by this particular initial conditions, they aren't uh, doing like what the last one did, where they all were acting like a single unit almost. I have noticed earlier today that they would do things, like I don't know if you noticed that, but the way they would, when they encounter, some of them, when I see one encounter the other, they will react and just change directions. I have seen them moving in groups, like this right here. I've seen that. It's hard to tell, like, what anything that really, really sticks out. I can just tell you that there's a lot of variation. And that's kind of what I wanted, was just a lot of variation, and they're all just competing. These two are fighting. Yep, just turned into food. It's getting gobbled up now. Up and over, up and over. See, that's a new behavior. That originally they were coded to just move left in one direction, and you see that one, for example, is moving up and over. I don't know what direction. Let's stop him for a second here. It's facing. Okay, well this one's facing north, so it sees this machine. Advanced time, and this one is facing. Oh, they're looking at each other here. They're looking at each other, and they're deciding to. Remember, originally they were coded to approach each other if they see another machine. Now these guys, they're looking at each other and deciding. So it's kind of like I would say it's a group behavior. They're working in a group. They look at each other, but they decide to not go after each other. Instead, they both move together. And maybe that's, to gain up on another machine, like a group strategy. I bet you these guys are probably doing that too then. Yep. Goes south, or it's looking south, and that one's looking north. That one's looking south. That one's looking north. So there's like a group, some kind of group cooperative strategy there. Yeah. So what I'll do is I'll run this for um I'll probably run it for like all week, and we'll see how things are. I don't. I feel like this is about where I want it to be now. Um, I can come up with new features and stuff. I'll add them in. But as of right now, it is. I feel like the bugs have been worked out pretty good this time, and I will be running long term and see what happens over time. All right.